Welcome back to Nick Does Maths, and today we are doing the bestest maths. We are doing statistics maths. So let's see what we can do. Let's see what we have. We've got a continuous random variable capital X, and it has a probability density function specified this way. 1x over 10 and 2 minus 2/5 x between 0 and 4, 4 and 5, then 0 otherwise. We're going to do all the things that you might expect that we want to do from all of this, which is we are going to sketch, we are going to state the mode, we're going to find the mean, we're going to find the variance, and we're going to find the cumulative distribution. Going to do all that cool stuff. How about we start? All right. So these are all linear, and really, right, we don't have to really kill ourselves that much on this one. Without really thinking about it, I've got a positive gradient, a negative gradient. What normally happens is I'm going to go up there. They need to join up. The only real kicker is knowing what's going to happen at the end point. So x is 0, we do start at 0. Point x is 5. 2 minus 2 is 0. So we're going to go down to here. And what we really want here is that height. Now, if we've done our job properly, we put in 4 there, 4 over 10, which is 2/5. And we want this to be nice and continuous. So if I plug 4 into there, 2 minus 8 over 5, that's 10 minus 8 over 5. That's 2 over 5. There we go. All right? So there we go. Part A. Part B, I'm just going to write here, state the mode. Well, where's the peak of my distribution? 4. Okay, now on to the fun stuff. We want e of x, so we're going to have to integrate x f of x, which does mean we're going to have to do it separately. So we're going to have to integrate x over 10 dx between 0 and 4, and we're going to have to integrate 2 minus 2/5 of x. So, hang on. All right, so it's f of x times x. So that's my f of x. Let's times it by x. Boop. And then 2 minus 2/5 of x. And again, it's f of x times x. Boop. And this one is between 4 and 5. So that's going to give me x cubed over 30 between 0 and 4 plus x squared minus 2x cubed over 15 between 4 and 5. What's that do? So that is equal to 4 cubed over 30 plus 5 squared minus 2 times 5 cubed over 15 minus 4 squared plus 2 times 4 cubed over 15. And we should probably check that. 5 squared minus 4 squared is something. Is something. Let's do the thing. 5 squared minus 4 squared is going to be 9 plus 64 over 30 minus 250 over 15 plus 128 over 15. 3. There we go. Back to the pouch. Bish, bash, bosh. All right. Let's therefore do D, find the variance. Well, we're going to have to do the same thing. That's my f of x. Except this time, we multiply by x squared. So that becomes x cubed, that becomes x squared, and that becomes x cubed. Again, we can't mush these together because different limits. So this becomes x to the 4 over 40 between 0 and 4 plus 2x cubed over 3 minus x to the 4 over 10 between 4 and 5. I mean, I won't fib, I'm not desperate to do this by hand, so let's just see what this is. So we get 4 to the 4 over 40. What's 4 to the 4? 16, say 256. Yeah, seems about right. Plus 5 cubed is 125, so 250 over 3. Minus 625 over 10. Minus 2 times 64, 128 over 3. Plus 4 to the 4, which you said was 256 over 10. That's 61 over 6. Apparently. So var of x is 61 over 6 minus 3 squared. E of x squared minus e of x all squared. What's 9? 9 is 54 over 6, so 7 over 6. I'll just put that there, actually. Just pop it there. Let's do that. Let's do that. Check, check. That's 7 over 6. All right, let's find the cumulative distribution. I've run out of space here on my board a little bit, so let's just make a bit more space. All that hard work gone. Always the same. Right, the cumulative distribution. Well, there's two obvious parts that I need to be careful of. There's going to be one thing for 0 to 4, and then 4 to 5, right? 0 to 4. So what I want when I'm in between 0 to 4 is I want that area. So if I'm 0 to 4, we are going to integrate from 0 to x, my f of x. But just to make my life less confusing, I'm going to use a dummy variable, t. You can use whatever you want, right? But it doesn't matter what we call that. But because I'm using x up there, that's what I'm going to do. And that comes out as x squared over 20. Okay, so the probability of being less than little x, so long as little x between 0 and 4, is x squared over 20. Now, what's going to happen at 4, funnily enough? Well, you could either plug it into there, which is 16 over 20. Or, just a triangle, 1/2 base times height, which is also 4/5. The point is that whole area there is 4/5. Okay, because if we're over here, what do we want? Well, we want this whole area, which we are going to split into these two parts. We'll put all this together nicely at the end. So we need that 4/5 plus the integral from 4 to x of 2 minus 2/5. And again, just for my own confusion levels, I'm going to use dt. You just need to integrate this, which is 4/5 plus 2t minus 2 t squared over 5, between 4 and x, which is 4/5 plus 2t, right, 2x minus x squared over 5 minus 8 plus 16 over 5. Ooh, running out of space there. So what's that? That is 4 over 5 and 16 over 5 is 20 over 5 is 4. So what does this become? Well, it's 0. Never forget these ones, right? My random variable lies between 0 and 5. So the probability of being less than a number that's smaller than 0 is 0. It's impossible. In the same way, you are guaranteed to be less than any number more than 5 because we are between 0 and 5. So we said it's x squared over 20 for x is between 0 and 4. And it's going to be, so we said 4 over 5 plus 16 over 5 minus 8 is minus 4. So that is 2x if x is between 4 and 5. We can check that. These do need to match up. So if I put in 4, I'll get, funnily enough, the 4/5. If I put in 4, I get 8 minus 4 is 4, minus 16 over 5. 4 is 20 over 5. 20 over 5 minus 16 over 5 is 4/5, which is what we want, and it joins up. Nick does stats. Nice little go through all the different things we can do with a continuous random variable. Bloop, check, 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 and all the pitfalls we can fall into. Did you enjoy that? In that case, subscribe, like the video, hit the bell for notifications. Drop me a comment. Did I miss anything? Do you have any snazzy tricks I could have done? Let us know. Otherwise, I will see you next time for a little bit more stats, probably. Bye bye.